you know, had to restart my surface a few times. Tell myself to pull it all together, you know, snap out of it. A little bit of a mental breakdown. It's all good. It's all good. We're here. We're here again. Okay, we're ready to learn. All right, so what I was trying to say was that your parent graph parabola is stretched by a factor of a if the absolute value of a is greater than 1. So what does that mean? Well, what that means is that here's your parent graph parabola, and if you can imagine somebody stretching my arms. Okay, so notice that my arms got stretched, they got closer to each other. Okay, so parent graph stretched, parent graph stretched. By a factor of a, that means that whatever your a value is in your equation, so if it was 2, parent graph doubled. If it was 3, parent graph tripled. Okay, 4, parent graph quadrupled. So whatever that a value is, that tells you how much your graph is being stretched. And the reason that it's the absolute value of a is because we don't really care if it's negative. The negative just tells you the graph is opening down, like we discussed in that other bullet point. I'm out of breath. Okay, so if a is bigger than 1, so even if it's negative, it just means it's going to get stretched upside down. Next, your parabola is going to be what's called compressed by a factor of a if, listen carefully, the absolute value of a is less than 1 but greater than 0. 0. And so basically, again, we don't care if it's negative. That just tells you if the graph's opening up or down. But if it is between 0 and 1, a fraction between 0 and 1, it's going to be compressed. So we've got parent graph compressed. Imagine somebody pressing down on my arms. So parent graph compressed. Let's say the a value is 1/2. So rather than increasing at the normal parent graph rate, it gets cut in half, or 1/4. Okay, so compressed gets wider, stretched gets skinnier. Compressed, wider, stretched, skinnier compared to the parent graph. All right, you know what? I think we're ready to graph our first parabola. So here we go. Example 1. First of all, what I want you to do is to look at the equation, and I want you to tell me, is it opening up or down? You should have answered up, okay? Because that a value right there, that +2, is telling us a lot about our graph. 1, it tells us it's opening up. 2, is it stretched or compressed? Is it getting skinnier or wider? Skinnier, stretched, okay? So since that's a 2, it's bigger than 1. Our graph is going to be skinnier than the parent graph is. All right, so we already kind of have an idea of what the graph should look like. Next, remember what the focal point of the parabola is? Most important point, pretty much? The vertex. And how do you find the vertex if it's in standard form? ax squared plus bx plus c. That handy dandy little formula. So if any of you are a big Finding Nemo fan, you got P. Sherman 42 Wallaby Way, Sydney. If you ask me where I'm going, I'll tell you where I'm going. I'm going to P. Sherman 42 Wallaby Way, Sydney. Dory, you know, she forgets everything, but she remembers that address. Well, how do you find the x value of the vertex? I'll tell you. Just the opposite of b over 2a. You ask me one more time, I'll tell you to plug it in. The opposite of b over 2a. You got the x value of vertex. There you go. Okay, so to find the x value of our vertex, the opposite of b over 2a. So our b value currently is -8. So the opposite would be a +8. So x equals the opposite of b, so +8, over 2a. 2 times the a value, which again is 2. So 8 divided by 2 times 2, which is 8 divided by 4, which is 2. So the x value of our vertex is 2. Again, how do you find the y value then? Plug it in, plug it in. All right, so you got the 2 over here that you're plugging into the original equation where the x is. And then you will know what the y value of your vertex is. So y equals 2 times 2 squared minus 8 times 2 plus 6. Order of operations, people. Exponent. The 2 right here is being squared. 2 squared is 4. And then 2 times 4 is 8. So then you have 8 minus 16 plus 6. 8 minus 16 is negative 8 plus 6. So negative 8 plus 6 gives you negative 2. So the y value of our vertex is negative 2. And now we pretty much know everything that we need to know to graph our parabola. So a little bit of work there at the beginning, 2, negative 2. Plot that point, that is our vertex. And we already know the parabola is opening up and it's being stretched because of that a value. So, one thing that I want to go over, that was on there from my first failed attempt to record this. Going back to that parent graph pattern that I said would be very important. Well, here it is. That parent graph pattern helps you plot the points on the side of the vertex. So if you recall, 0 squared is 0, so that's kind of like the vertex. But 1 squared is 1, 2 squared is 4, 3 squared is 9. Since your a value is not 1, okay, it's getting stretched by that factor of 2. What it is doing is it's multiplying your y values by 2. So if you were to look at just the first term in your equation, you're taking that x value, so let's say you're going over 1 x value from the vertex, squaring it, you get 1, but then you're multiplying it by the a value, okay? So you actually end up getting 2. So I'm going to make a chart over here, and I'm going to call it the over-up, since our graph is opening up. If from the vertex, you're always going back from the vertex, you go over 1 x value, so 1 block. Normally, 1 squared is 1, but you're then multiplying it by your a value, which is 2. And so now you're going to go up 2 spaces. So still over 1 from the vertex, but up 2. So over 1, up 2, instead of the normal over 1, up 1. Next, if you're going over 2 x values from the vertex, normally 2 squared is 4, but that's being stretched by a factor of 2, that a value. So now you're going up 8 values. So over 1, 2, up 8. Okay, normally, according to the parent graph pattern, you would go over 3, up 9, but that's being multiplied by a factor of 2, so you go up 18. So over 3x values, up 18. That kind of falls off my graph, so I'm not going to worry about plotting it. And since you've got one side of your graph done, and they're symmetrical, it's the exact same thing on the opposite side of your parabola. So over 1, not up 1, up 2, because it's stretched by a factor of 2. Over 2, normally up 4, but up 8 this time. So you should notice that this parabola is a little bit skinnier than that parent graph parabola that we saw earlier, okay? That's because of that a value of 2. So, important points, the vertex. You need to have the vertex labeled. It was the point 2, negative 2. And then you need at least probably 2 points on each side of the vertex in order to be able to tell what's going on with your parabola. So I'll be looking for that. Next, we were asked to label the axis of symmetry. And if you recall, that's just the line that's cutting through the center, which is the x value of the vertex. So x equals 2. And there's your parabola. Cool? All right, one more for today's lesson, example 2. If you take a look at the equation, y equals negative 1/2 x squared plus 8x minus 30. So again, we should already kind of know what this graph looks like just based off of that a value. Negative, what's it say the graph is doing? opening down. 1/2. What's it say the graph is doing? It's being compressed. So this one will be a little flattened out compared to the other one, but opening down. All right, so where do you start? The vertex. How do you find the vertex? I'll tell you how to find the vertex. The x value of the vertex is the opposite of b over 2a. All right, so x is the opposite of b over 2a. In this case, our b value is positive 8. So the opposite would be negative 8 over 2a. 2 times our a value, which was negative 1/2. Simplify, negative 8 divided by negative 1. A negative divided by a negative is positive. So we have positive 8. Next, how do you find the y value? Plug it in. So y equals negative 1/2 times 8 squared plus 8 times 8 minus 30. Just plug it in. Order of operations, exponent first. 8 is being squared. So 8 times 8, I ate 8, it got sick on the floor, is 64. And then we got another 8 times 8, 64. But negative 1/2 times 64 is negative 32 plus 64 minus 30. Negative 32 plus 64 is positive 32. And 32 minus 30 is 2. So our vertex is the point 8, 2. There it is, okay, 8, 2. Next, you need to fill in the sides of your parabola. And again, going back to that parent graph pattern, the over up, but instead this time it's down, so the over down. And again, always over from the vertex, so the over down. Normally, if you go over one x value from the vertex, you're going to go down 1, but that is being compressed by our a value by a factor of 1/2. So instead of going over 1 down 1, we're only going to go over 1 down 1/2. So over 1 down 1/2. And since it's symmetrical, it's the same on both sides. Okay? Only down 1/2. Next, if you go over 2 x values from the vertex, normally 2 squared is 4. But that a value is cutting it in half. So you're only going down 2. So over 2, 1, 2, down 2. 1, 2, down 2. See how it's not increasing as quickly on the sides as the parent graph? Or the one that we just did where a was 2. If you're going over 3 x values from the vertex, normally 3 squared is 9, but that's getting cut in half. So only 4.5, 4.5. So over 3 x values, 1, 2, 3, down 1, 2, 3, 4.5. And then it kind of falls off the graph over here, but that's okay, you can extend it. So you could even say it going over 4. 4 squared is 16, but 16 cut in half is 8. So over 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. Over 4 down 8. And then you should be able to fill in the curves of your parabola. And there you go. I'll freeze it there for a second. So again, it's opening down and compressed by a factor of 1/2. And you should have known that just by looking at the a value. All right, opposite b over 2a tells you the x value of vertex. So I have an example page for you. We'll do vertex next. But if you have a color copy or looking at it in color, it says graphing quadratics practice. And the first 2 are in standard form. So I want you to try those 2 on your own. Notice it says label the vertex. I don't have axis of symmetry, but you can label the axis of symmetry if you want. The axis of symmetry for the last one that we did would be x equals 8. That was the x value of our vertex. So, good luck. If you have any questions, you can email me or comment on the video. Also, I noticed on my first trial video that there were 10 likes and 2 dislikes, so I'm not quite sure what that was about, but whatever. We don't care. Stay safe out there. Until next time, come back for Vertex form. It'll be just as fun, and I'll keep little buddy safe here, okay? Oh, forgot your workout. If you want to stay active and keep moving, do 3 minutes, as many as you can, as many rounds. Do 5 burpees, 10 push-ups, 15 air squats for 3 minutes. Do as many rounds as you can. Take a break, do it again. Okay? But I don't know, stay active. Go take a walk. I know it's a little rainy here and there, but like, get some fresh air. Okay? Bye. I'll see you next time.